The AI wrote code that works flawlessly. So should you even care which architecture that it chose? Senior.NET devs, here is you already know this reminder. Working code is only the first test. Your team must change it next month. Another developer and agent must understand it next year. The next AI session must add to it without inventing a second way to solve the same problem. In my last video, I just showed a Blazor pattern where a page asks one UI service for one page model through one call. And the natural pushback is simple. Why bother? Let the AI write the code. It works, ship it. An AI can inject our services into a Blazor component and call each one, render the right result. It can also build a page-level UI service. It can create an API tailored to the page. All three versions pass the same test, but they do not leave the system in the same state. One puts coordination in the component. One puts it in a service. One adds a network contract. Each choice changes how the feature gets built, how access checks work, how many calls across the network, and where a developer looks when something fails. The code works, but the choice still has a cost. AI makes local choices. It sees the task and the files in the context and the guidance that you give it, and then it picks a path. That path can be sound. The problem starts when the next task gets a different context and picks up another sound path. Feature 1 uses page service, and feature 2 calls domain services from the component. And feature 3 adds a generic repository. Feature 4 skips the existing result type and throws exceptions from the controller. Each feature works, but together they create a code base where every change starts with a new design debate. Now, I've spent 29 years building software, including systems used by 10% of the Fortune 50. The hard part has rarely been making one block of code run. The hard part is keeping hundreds of choices clear enough that a team can change the system without fear. AI lowers the cost to making each choice. It does not remove the cost of living with all of those choices. This is why cheap code makes shared architecture more important, not less. Code cost is what it takes to produce the feature today. Change cost is what it takes to understand, support, test, secure, and revise that feature for years. AI cuts code cost, but a shared architecture cuts change cost. The answer is not to hand design every class before AI starts. That would waste speed that AI gives us. But the answer is architecture the AI can inherit. Write down the choices that should stay the same across features. Put those choices where both developers and AI can find them. Back them with working examples, tests, and build checks. For a Blazor system, that may mean a page uses one page-level read service when it combines several data sources. The server enforces access. Writes go through the domain services. API methods use the shared result type. Integration tests cover the seams where data, access, and transport meet. These are not prompts for one chat, they are system choices. So here's what you do. Use the 3-feature test before you accept AI written code. Do not review the feature as if it will remain alone. Picture the next 3 features built from this and ask 4 questions. If AI copies this design 3 times, will the system get clearer or harder to follow? And does this code use the same path for data, access, errors, and tests as the rest of the system? Could a new developer find the rule that led to this design? And finally, can a build or test catch the most costly way this pattern could drift? If those answers are weak, then the code is not done just because it runs. So here's the rule. AI can make local code work. Architecture makes all the local choices from one system. This is a small example of intelligent engineering, the operating model for engineering organizations in the AI era. It's what comes after vibe coding. The goal is not to stop AI from writing code. The goal is to give AI context, rules, and checks needed to create software that the team can trust, support, and scale. So let AI code, but give it an architecture it can inherit. I'm Chad Carter. I defined intelligent engineering, and I built DevNitro, which is the platform that runs it end to end. You already know what you're doing, so now go and build the software that your team can trust and support and scale. And hey, if this helped, you know the drill. Plus, you may want to go ahead and share this with a developer that you like. And I'll see you in the next video.